As we go on to section 3, now these are sections that are included in our Math 105 curriculum. So we'll spend a little more time going over them. An interesting point about that last formula we did in section 5.2, that is the finding the center of a circle formula where you know the radius, and that was a rather complicated one, and that is preparing you for pre-calculus. And keep in mind, this is a college algebra book, which many of the things we'll be doing here are used in pre-calculus. So the topics we're going to cover now is we're leaving the area of multiplication and we're going into equations, polynomial equations, and factoring. So graphical solutions, and we gave a hint of this in section 5.2. The principles of zero, which we introduced there as well. Terms with common factors, factoring by grouping, and then factoring and equations. Now in example 1, they're asking us to solve this particular equation. But notice it's a quadratic equation, that is to the second degree. And we haven't done any of those yet. But as we mentioned in chapter 4, we did some finding the zeros, which relates to this topic here. So let's go on. Now, if we graph this, and we're not going to graph it because we're not using a graphing calculator, we're going to use what is called the zero method. So I'll go through this carefully and again take notes. So there is our basic equation, and what we're going to do to use the zero method is to get our equation to equal a zero. So we take this term, transpose it, and that gives us this. Now, if we were to put that into a graphing calculator, it would look like this. Now, an interesting thing, the parabola that comes from graphing this quadratic equation passes through the x-axis at this point and this point. Now, what did we say the value of y, this y here, was when it passes through the x-axis? Well, y is going to be 0. So in a sense, we have this. Now, the technique we're going to use to solve this without graphing will be to factor this. And we'll be reviewing this a couple of times. So let's factor that. X squared minus 6x equals 0. Now, is there a common factor here? And the answer is yes, it's x. So we're going to factor out the x, and we end up with this. Now, we have two factors that are equal 0. And a little later, they're going to say that if we have two factors like a and b that equals 0, the only way that can be true is if either the a or the b is a 0. So A times B, if A is 0, is 0. If B is 0, 0 times A is 0. So we use that principle of the zero factor to equal each of our factors to 0. And we usually write it this way. X is equal to 0 or x minus 6 equals 0. So here, x equals 0, that's one of the solutions. And here, x, when we transpose the 6, the negative 6 becomes a positive 6, and there are our answers. X is a 0, x is a 6, when y over here is 0. So again, this is the zero method, finding the zeros. When y is 0 and you were to graph it, what would be your x values? Well, x would be a 0, x would be a 6. And we're using the factoring method of doing it, and we'll follow up on this as we continue in the lesson. We're going to be repeating this a couple of times. And here they're saying 0 and the roots. These are called zero functions, finding the zeros. This group, we can replace this, we said, with a y equals 0. So when y equals 0, what are the roots of a quadratic equation? And we're going to use the technique of factoring. Now, here we're going to find the zeros by using the graphs of these various functions. So, without getting too involved, and we're allowed to use the graphs, if y is 0 here, in fact, we can make a little t-chart. This is what we did in Math 100. And we have a value there, a value there, and a value there. So y has 3 values. And when y is 0 here, x is a negative 2. When y is 0 here, it's a positive 2. And when y is 0 there, it's a 3. That would be for this one. And for this one, again, a little t-chart might be useful. X, y. We're looking for when y is 0. And we have right there is negative 2. This one is a 2. And this one is a 3. And if we make it bigger, we see the same thing. Okay? Now, that's using graphing, which, again, we're not featuring in this course. And they're just showing you the techniques of using the trace when you graph it. We're skipping that part there. So here's where they introduce the principle of the zero product. For any real number, a and b, if we have, as we mentioned before, ab equals 0, this is only true if either a or b equals 0. So if we can factor something into its factors and have it equal 0, this would be a way of solving quadratic equations. So noticing here, this is a factor. This is a factor of this up here. And if we have this equals 0, we then get this. This would be like our A. These two terms would be like our B. So we say our A equals 0, which is 3x equals 0, or x plus 4 equals 0. Here we're going to divide both sides by 3. We get x equals 0. Here we're going to transpose the 4. It becomes a negative 4 on that side. So the solution to this quadratic equation is it could be either a 0 or it could be a negative 4. And let's check it to see if it works. Well, if it's 0, 0 squared is 0, 3 times 0 is 0, and then 12 times 0 is 0. So this one works. Now, if it's a negative 4, well, we're going to go negative 4 squared is a positive 16. Positive 16 times 3 is 48. So this, with a negative 4 in there, is a positive 48. Plus, a negative 4 times 12 is a negative 48. And does that equal 0? Yes, it checks. And the method we used, we set it up in what we call standard form of the quadratic equation. That is, all the terms are on this side, equaling it to 0. Then we factored this by taking out the greatest common factor. Then we took each of the factors and equaled it to 0, and then solved those two mini equations. And we checked our answers, and it's a solution. Wow. Now, in example 3, here they already have it in factored form. But where did these factors come from? Well, if we FOIL this, we get x squared, a negative 3x, a positive 2x. When I group like terms, I get a negative x, and then a negative 3 times 2 gives me a negative 6 equals 0. So this might have been our original quadratic equation in standard form, and we're asked to factor it. Well, when we factor this, we end up with this. We then say take this, equal it to 0, or that, equal it to 0, and we get, when we transpose that, a positive 3. Transposing that, we get a negative 2. Now, if we look at the graph down below, we see if we were to graph that original trinomial, it would make a parabola that looks like this. And when y is 0, right there, again, a little t-chart might be in order. And we have two places where y is a 0. Our x is a negative 2. And our x over here is a positive 3. The same answers we got when we factored that trinomial into this. Again, your y would be a 0. and it checks out. Now here we're showing you what's going on, and again through practice, once you know the procedure, and they're saying that here we have this function, and this is y, and we're going to say that y equals 0. Okay? And they're going to say, well, substitute all your x's with the letter a. So here, this becomes an a, this becomes an a. So we just have that. And we have it equaling 0. So how do we do it? We take each of our factors and equate it to 0. Here we get a is 0. We're going to transpose the 2, get a negative 2. Then we get 3a, or the a is there already. We're going to divide both sides by 3, and we get a equals a negative 2/3. Now, when we graph this, again, our y-axis, we're looking at the 0, and then along the x-axis, we're looking for the x-intercepts. Well, here it's a negative 2/3, which is this value right here, and a 0, which is this value right there. So they're giving you lots of stuff, and perhaps my job will be just to think of a way to make some challenging material a little easier. So here they're saying if we have, back in earlier sections where we talked about the distributive law, we can distribute a times b gives us ab, a times c gives us ac. We can reverse this by taking out that common a, that is factoring it. So when you have something like this, they're asking you to take out the greatest common factor. And the greatest common factor here is there's a 6 in each one of these. So we can take that 6 out, put it there, and then end up with this in a parenthesis. And you check just by distribution. So again, this will be a review of what we did in section 5.2, which we sort of skipped in this course, but you'll be doing some of it to be sure your factoring was correct. Now, in this example, by the way, they're showing us a very good thing here. Suppose instead of taking out the greatest common factor here of 6, you took out a common factor of 2. And you might say, is that good? Well, it's a start, but notice what you have left in the parentheses still has a common factor of 3. So when you pulled out that 3 from this, you then would get 2 times 3 is 6, which would then take you to what MathLab would give you credit for as a correct answer. Where this is not incorrect, that you've taken out a 2, you haven't taken out the greatest or largest common factor. So when you have something left in a parenthesis that still has a factor you can take out. You didn't take out the greatest common factor. Now, in this parenthesis, there are no more common factors. So let's go on here. So notice in this one, you could take out a 5 and a 5, but that wouldn't be the greatest common factor. You'd have to take out a 10 for the number part, and then for the x powers, you take out the greatest common factor you can take out of each letter, which is usually the lower number. So you can take an x to the 4th out of each of these two, and then you get your answer. Okay, so for example 6 now, and again we're looking at technique. What we want to decide, what is the greatest common factor of a number? Now if it was only 8 and 4, we could take out a 4. But since we now have a 10, the greatest common factor of each number will be 2. Then we look at p to the 6th, p to the 5th, p to the 4th. The greatest one we could take out of each term is p to the 4th. That is the smallest exponent. And then q to the 2nd, q to the 3rd, q to the 4th, you could take out q to the 2nd out of each term. And again, if you need more help on any section, as you look over your textbook, my advice would be to look at it again carefully. Thus, 2p to the 4th, q to the 2nd is the greatest common factor you can take out of each term. And you can check by distributing. We then say, if there are no more common factors inside the parenthesis, you have factored it completely. Now, suppose this is what you had originally, just what's in the parenthesis. You can't take out any more common factors. We say this is a prime polynomial. So originally it was what we had. Then we took this out and we had this. So what's in the parenthesis now has been factored completely. It is a prime polynomial. And this is what we factored out of each term. And that's what you'll be doing in your practice and in your quiz me to indicate you've mastered this. Now, in some cases, as you look at this one here, this is example 7. Let's look at this a little more carefully. We have a 15, we have a 12, we have a 27, we have a 3. What can we factor out of all of these as far as the number goes? And the answer is a 3. And in terms of the exponent, again, the lowest is x to the 2nd. We could take that out of each term. Now, an interesting thing, when you get to the end of this, you might say, well, I'm factoring out 3x squared, which is what you've done. But you have to remember there is a -1 still there. And that's what they're showing. That -1 is very important, because if you distribute this, to get back to this term, you need to have that 1 there. Okay? If that 1 wasn't there, you wouldn't have a place to put this. That is very important. Now, if it were a positive one, it'd be the same. You would need the 1 there. Okay? And now what's left in the parenthesis has no more common factors. Okay, here are some examples. And here they want you, and this is critical for your skill for chapter 6, they want you to factor out something with a negative coefficient. So as we look at this, we see we have a 4 that's common, but we're going to factor out a negative 4 because we want a coefficient that's negative. So now what's left there? An x. And what's left there? Now, this would have to be a positive 6. So notice by factoring out a negative 4, you have reversed the signs of what's left inside the parenthesis. Again, a very important technique that we'll be using in chapter 6. Now for B, we have a negative 2, a 6, a 2, and we have an x. So we're going to take out a negative 2x from each of these terms. And a strategy would be to do something like this. Put your parenthesis there. So what's left here? Well, a positive x squared, a negative 6x, and here we're going to have a positive 1. Notice we've changed all the signs of what we have in the parenthesis. This was negative, now it's a positive. This was positive, now it's a negative. This was negative, now it's a positive. And if we distribute, we get back to where we were. We got there by factoring out a negative 2x. And they have it here as well. Okay, example 9 is the height of a thrown object. Suppose that a basketball is thrown upward with an initial velocity of this and an initial height of 0 feet. Its height in feet after t seconds, height after t seconds, is given by this function. Okay, let's see what they want us to say about this. It's on the next page. So there's a picture. They're throwing up, did I say a basketball? It's a baseball, looks like. Now, we are asked to factor out a negative t, a negative 16t as follows, which we do, and we get that. Okay. I'm going to go back to see if I left something out of my question. Did they want us to do something with this? Nope. They didn't want to ask us about what the height is at any particular time. But if we're using our graphing calculator, we could set up some values for this. And we're now going to summarize then tips for factoring. Factor out the largest common factor if one exists. The common factor multiplies a polynomial with the same number of terms as the original polynomial. Okay. And factoring can always be checked by multiplying. Multiplication should yield the original polynomial. Okay. All right. We're now going into another method of factoring, which is called factoring by grouping. And here they ask us to factor this term plus this term. Do we see in these a common factor? Yes. B, A minus B, A minus B. So what do we have then? Well, they gave us a really difficult one to start with, but that's okay. We'll just follow it through. A minus B, A minus B. So there's our A minus B that we are factoring out of these two terms. So we're left then that it's A minus B times this plus this. Now we can group like terms here because there is a common x, and we get 2x plus 5 minus this times that. Again, this is a rather difficult one to give us as an example of how to factor by grouping. We're going to have some easier ones coming up right now. Okay, example 11. Let's factor out what we can here. Well, when we are factoring by grouping, what we do is we think of them in terms of this group, we can factor out something, and this group, we can factor out something. So there's that first group, we can factor out an x squared. And in the second group, we can factor out a 4. We then take our common factor. They're putting it first. I used to put it over here, but that's okay. And then we're bringing this into this other parenthesis here, and we get that. So it's sort of a reverse of what I showed you briefly in chapter 5, section 2, where you're going to multiply this by that and this by that. And you can check, and it does check. All right, in example B, let's see if we can do this one here. If we keep it in the same form that is present there, let me raise it up a little bit so we can see the work here. I would have done it a little differently than this. In fact, I would have said, let's regroup this and put it in descending order. So I'm going to show you that. Okay, I pause it to save a little time. I have written this in descending order, and out of the first two terms, I'm factoring out 4t squared, and I get t plus 5. Now, in order to get a t plus 5 out of these second two terms, I have to factor out what? Remember, we just had the technique of factoring out a negative something to change the signs. Well, I'm going to factor out a negative 3. So now I would take this term and this term, I'd put this one, the way I do it, t plus 5, and then my 4t squared minus 3. And they get the same thing over there. Okay? Again, this way it's not going to work. So we had to reorder these to put them into some sort of situation where you could factor out common factors. All right. Now here they're going to show us that we can sometimes change the signs of something by factoring out a negative 1. So by factoring a negative 1 out of here and using the commutative principle, I get a negative 1 times a minus b, or just a plain negative a minus b. So all of these are equivalent. And now let's factor this next one here. And they have it written out. In class, we'll be doing some of these on the board and showing you how it's done. And again, here they are too. So for these two, we're going to be factoring out a common x right there. And that's what they got. Here, a common y. Okay? Now, notice if we had factored out a negative y, which is what this becomes, I then get my common factor of a minus b. So then when they're placed in their parenthesis, I do it the other way, but you get the same answer and that's fine. Okay, this tape is going to be the longest one I've done as we approach 40 minutes. Wow. So now we're asked to solve this equation by finding the zeros. So we're going to get 6x squared. I'm going to transpose that, get a negative 30x equals 0. This is now in standard form of the quadratic equation. I'm going to factor out 6x from both terms, and I get x minus 5 equals 0. I'm going to equate each of these, and we have the work, we can pick up on it down here, to 0, and I get x equals 0, x equals 5, and it went my little t-chart here, x, y, finding the zeros when y is 0. We have here a 0 and a 5, and that's what we have. Okay. And the technique we're going to be doing is solving these quadratic equations by factoring. Write an equivalent equation with 0 on one side, factor out the other, take each factor, equate it to 0. That's the technique we've been using. And that will wind up this section. just at 40 minutes.